So while page 23 was part of your homework, there technically was something that might have thrown you for a loop that you had to do by hand that you might not have been prepared to do. So let's talk about that. First of all, in the first question, do the assumptions, and that's fine. You would have done that LINE, and I probably would have shown those up here by the graph. You know, the equal variance in the residual plot. Oh, wait, that's normal. The residuals are fairly normally distributed. Equal variance in the residual plot. Defined the R, and that this graph looks fairly linear. All right. Next would be Part B, which asks you to test an appropriate hypothesis and state your conclusion. So you need evidence, statistical evidence, only with a p-value. So therefore, we need to have a t-score and a p-value, and there is the problem. Because this computer printout does not include some important information. What's missing? Yeah, and they put it usually T ratio, and then what else? Right, so those two columns are missing. Hence, there's our problem. So what we're going to do is I'm going to teach you how to get your t-score and your p-value by hand without when it doesn't give it to you. So first, let's, beta is the slope of the relationship between mortality rate and education. And real quickly, we know that our null hypothesis would be beta is 0, and our alternative is just asks for an association, so that is two-tailed. Linear regression t-test, and so now let's do the test statistic. That is the t-score. All right, that is akin to x minus the mean over the standard deviation, okay? But it's about slope. So it's the sample slope, the slope statistic, minus your hypothesized value, your hypothesized slope. That's the mean or the expected slope value. That's the x minus the mean. That's the expected hypothesized slope over the standard deviation of the slope. So let's go ahead and fill in these numbers based on what we have given to us. So what, according to this computer printout, is the sample slope? Negative 49.92. So that is our sample slope. What is the hypothesized slope? That's from here. What is the hypothesized slope? 0. Over the standard deviation of the slope, which up here is 8. So that comes out to be negative 6.24. So if these are all the slopes that I could have, our slope is like way down here, okay, at negative 6.24 standard deviations down. So I want to find a p-value. How do we find p-values when we have stuff like this? Norm CDF, but here we're going to TCDF. And which way is more extreme? If my sample slope is down here, which way is more extreme? To the left is more extreme, because to the right gets close to your hypothesized value. So more extreme, there's my slope, or something more extreme if the null is true, so that's negative infinity up to that hypothesized t-score, or that t ratio. Common degrees of freedom, which is 56 up there in the computer printout. And so that comes out to be something, it's around 3, it's like 3.08 or something, times 10 to the negative 8. So essentially 0. Okay? Now, quick little warning, this is the p-value for one tail. and this is a two-tailed test. So technically, I would multiply this value times 2, and it's pretty much still going to be a p-value of about 0. Okay? Okay, so in summary, to do the t-score of, and here I got that value, and the p-value by hand, I had to do b minus 0 divided by the standard deviation of the slope. That gave me my t-score, and then I TCDF'd to get the p-value. Okay? So now you know all of those extremes. So, I'm walking you through all the different ways that you can be given information and then how to run a linear regression test from that. Okay, so we've seen it when it's been in a list of data. So, in fact, I'm about to reference this. So I want to remind you that we have learned how to get a test, run a linear regression test when we are giving a list of data. Okay. And then, of course, a computer printout. Now, we're about to do this on our notes. In the notes on page 24, I'm about to ask you to interpret the standard error and the standard deviation of the slope, standard deviation of the residuals, and standard deviation of the slope if all I give you is a list of data. Okay? So, when I first saw that, it kind of freaked me out. How can I figure out what do you expect to be able to do to figure out the standard deviation of the residuals and the standard deviation of the slope if you are just given this set of data? What's your first instinct to do with that stuff? Put it in stat edit. Okay, that's your first instinct is to go put this stuff into stat edit and run a linear regression test and see what it gives you. So let's turn to page 24 and see what kind of information that gives us. So on page 24, this is what you will do when you need to describe and write about the standard deviation of the residuals and the standard deviation of the slope. But what you have been given is lists of data. So you're going to take that list of data and you're going to run a linear regression t-test, and from that you get this data printout below. Okay. So this is a problem, so let's kind of get to the context of this because we're going to need it. So this is a problem about image quality and time to that it takes a person to read a passage. Do you remember that problem? When we had image quality and time it takes a person to read a passage. Which was the x and which was the y variable, by the way? Image quality is the x, and time to read the passage was the y. Okay. So notice this printout that our calculator gives us. What numbers or what variables in there makes you think, ooh, that's probably some standard deviation thing I need? What do you think? What there you think is standard deviation? S? Think that's a good guess? Yes. S is one of those standard deviations. And this isn't in our book. I had to hunt and peck on the I had to search on the internet. I didn't even really find a clear cut for this. I had to figure this stuff out for myself on this page. This S here is the standard deviation of the residuals, just like when you have a computer printout. When you have a computer printout, such as this, see this little S right here? What's that S? Which S is that? Standard deviation of residuals or slope? Yeah, see, so that plain S in the computer printout and the plain S in our calculator printout is that standard deviation of the residuals. Okay, so good. That's given to us. No problem. Let's go ahead and interpret that. So let's recall the phrasing we use to interpret the standard deviation of the residuals in context. Okay? All right. So what's our phrase that we use for interpreting the standard deviation of the residuals? Thinking of our song. Of residuals. The average amount that the actual y value point. Okay, so here we go. So the average amount that the actual y is time to read a passage. So the average amount that the actual y value point varies from what's predicted to become, varies from what predicted what? Good. Varies from the predicted time to read the passage. So it's about y's, actual time to read the passage, and predicted time to read the passage. Okay? Is 0.25 seconds. So that's the average differences from expected. Okay, very good. So no biggie there. However, the standard deviation of the slope is not on the calculator printout. Okay? So that's quite annoying. In fact, I would go so far as to say that is we're going to have to do this by hand, and that is a pain in the butt. Okay? Dadgummit, that's a pain in the butt. In other words, the standard deviation of the slope that I have to do by hand is b over t. Bot. b over t. Okay? See, no song here, but there is another way to remember, okay? Not everything's all about the song. Most everything is, but okay. So b over t. So now the b and the t are on the calculator printout. That is this b and this t. So now I can get the standard deviation of the slope. So I'm going to say that equals negative 0.35 divided by negative 3.10, which is 0.113. I'm just going to call it 0.11. And now I have the value, and I'm going to interpret it in context of this problem. So let's see here. Okay, so how's my thing go for this? This one is like, yeah, if you sample many times. Okay, it's like one of those screaming ones. If you sample many times, I'd expect the slope you find, the slope of the relation between image quality and time. Will vary this much. 0.11 on average over time. I'm going to put over time there. So there you go. If you sample many times, I'd expect the slope you find of the relation between x and y to vary this much on average over time. Okay, that's it. So that's kind of a review of the phrases, but then also how to get those things when all you have been given is a list of data. All right. So I think I've run down all the different formats of data you can be given and how to find everything you need to find from those. So your assignment starts on page 25, which is the next page, and you see one page that's exactly like what we just did. And then page 26 is your warm-up. And, again, do be aware that, say, if you have, when we say, is there evidence of an association, and we're going to do a phantoms here, there's not really a ton of room there. So I recommend that you do your LINE conditions. You're more than welcome to do those up here by the picture. You could put, here's linearity, and put what R equals, and then reference that graph. What would this one go with? What would this graph go with? This one would demonstrate equal variance in the residual plot, so I would talk about that here. So equal variance in the residual plot. What would this graph demonstrate? It's the normal probability plot that the residuals are fairly normally distributed. Okay? So the only one that doesn't go with the picture is independent and random, and you could probably put that here, and so on. Okay, so just use your space wisely on that. The next page doesn't have a number. There's no number on this page. There's also no questions on this page. This is just a summary sheet of everything you need to know about this chapter, including, this t-score here, b minus the hypothesized value over the standard deviation of the slope, okay? So that's just I actually made that for our AP review packet, and I thought I'll just throw this in here because I hadn't copied it yet. And then pages 27 and 28 are the first two pages of the test review. We quiz on Monday. That's why you're doing the warm-up. And we are starting the review so that we have time, so we're not bombarded with too much to do on Monday. All right, page 20, so 25 to 28. You can go ahead and start. And I'll walk around helping you make sure that we are working today and I'm not distracting you.